Okay, here it says let f the function given by fx equals sine phi x plus pi over 4. And let px be the third degree Taylor polynomial for f about x equals 0, which is called a Maclaurin polynomial. Then this series, in the case of Maclaurin, is about x equals 0, having one x enough close to x equals 0. When it is far, the error is greater. This is the Maclaurin, fx equal f0 plus f prime 0. This is 1 times x plus f second at 0 2 factorial over 2 factorial x to the 2 and so on. And here you can say f n 0 n factorial over n factorial times x to the n. And here f n plus 1 0 n plus 1 factorial x to the n plus 1, and it follows. It keeps going, you know?
Yeah.
Okay. Find the coefficient of x22 in the Taylor series. It means in the Maclaurin series. This n equal 22. Find the coefficient of x to the 22. This coefficient is going to be f, this derivative at 0 over 22 factorial x to the 22. Then, what happened? It is if you go this way and you stop down here, you get an error, right?
Yeah.
You get an error. And this error is in some way related with that one. But if you go to n equal 21, you get an error that is in some case related with this one, okay? So over here is not clear if they are asking the error up to n equal 21 or n equal 22. But since they are asking you to find this coefficient, I'm going to assume that they are using the Maclaurin series up to n equal 21, and they are worrying about this error using this formula. This is an assumption. It is not clear over there, but it's not going to change the nature of the problem or of the solution. It is not this the error. It says that the error is about, and this is the Lagrange error formula, absolute value of f to the n, I mean the derivative n, whatever it is n, a number over here, let's call a to the n over n factorial, and this a is between 0 and x. But to know this error, you have to talk about one x and a specific x. In this case, the error is about absolute value of n to the 22, the 22nd derivative, times 1a to the n over 22 factorial where a is between 0 and x. Remember that the function is fx equals sine phi x plus pi over 4, and we are trying to find the approximation for x to the 22, but in fact I calculate it for x to the 21st because I use the number 22 at the Lagrange error formula. But here it says the third degree. Then we'll find this and then that for the third degree Taylor polynomial or Maclaurin. And we get here fx equals sine phi x plus pi over 4. The first derivative with the phi here, cosine. The second, using the chain rule, gets phi gets out from here, and then now it is phi square for n equal to with minus sign, and it keeps going. The exponent of phi growing, and up to the n equal 4, we are right here. Here the sign changes because of the derivative of the cosine is minus sign, and here again changes. Now it keeps with positive for n equal 5, then this is a group of 4 that repeats, but the exponent is increasing. See the formula for n equal 4 is 5 to the 4, for n equal 3, 5 to the 3. Taking a look to the pattern, you will find here the 9th, which is the same like that, but the exponent over here, and the 13th, and the 17th, and the 21st. You have to check this, but this is the idea. 5 to the 22. It is cosine, then it's gonna give minus. Here is a cosine. Minus sine phi x plus pi over 4. Remember that the A of the Lagrange formula for the error is between those values, between 0 and x. Then this is the Lagrange formula, and you get here the absolute value is, it doesn't matter if we take absolute value. Here is the formula, and then you get that equals to, this is positive, can go out of the absolute value, phi is positive, 22 factorial positive, and you get here the absolute value of this sign. The sign of an angle is always less or equal to 1. Then you can say that the error is less than this, and then because the A is between 0 and 1/10, but here you can bound this with the same numbers and using 1/10, 22. And then you get something like that, that it is smaller than 1/100. But this is really small, okay, because of this exponent. Then reviewing the question, I see here that they are using the third degree Taylor polynomial. Then, when you use the third degree Taylor polynomial, the error is of order n plus 1. That's why I use the 22 derivative, the 22nd derivative. Then, when I go to 3, this is 4. Then, we'll use just this derivative, but again, it's just the same, but with the exponent 4, because we are going up to the third degree polynomial. Then, with 4, you get this formula, And instead of that, you get the error for the third degree polynomial will be of this order. The error less than is 5 to the 4 or 4 factorial 1/10 to the 4, you know? And it gives you something like, here is much more easier to calculate. 5 times 5 times 5 times 5 over 4 times 3 times 2 times 1 to the 10 to the 4, and you get here something like, see, this is 25, 125, right? Wants us to show that it is less than 1 over 100. Then it is easier to show with a calculator, but I'm trying to do it by hand, you know. And see, we have here the 25 times 25. Oh, all right. And then we have a 24 here. Okay. And 1 over 100 times 100. And what about these numbers? This is, remember, this term is almost equal. You can use a calculator, but those are almost equal. It is about 25 divided by 100, a bit bigger than 1/4, a bit bigger, times 100, you know. It doesn't surprise us that this gives less than 100, you know, because over here the error is extremely low, but here may be bigger, but less than 100, which may be the question over here. When he says error bound, I thought at first using the order 21 Maclaurin polynomial. But when he says here third degree, I changed this and again gave me less than 1 over 100.